Hello guys, welcome back. In this video, I will introduce you with one of the low cost and easy to use temperature and humidity sensor DHT11. In this video, I will use Arduino Uno board to measure the temperature and humidity using DHT11 sensor, and in the upcoming videos, I will show you how to use this sensor with the microchip PIC microcontroller, the Cortex M3 microcontroller and the ESP8266 Wi-Fi module. So guys, this is our DHT11 sensor. You can see these three pins 1 2 3 1 2 3, but in actual sensor there are 4 pins 1 2 3 4. So out of these 4 pins only 3 are used and the one pin is not connected. So in this PCB, what the designer has done, it has bring out the pins which are used. So I purchased this sensor from the kidsguru.com website. If you purchase this sensor from any other website with 4 pins, make sure that the data line is pulled up. As you can see, these 2 resistors are there. One is for LED and the one resistor is to pull up the data line with VCC. Now we will learn about the communication with this sensor. The interesting thing in this module is the protocol that is used to transfer the data. All the sensor readings are sent using a single wire bus, which reduces the cost and extends the distance. On DHT11, the one wire data bus is pulled up with a resistor to VCC. So if nothing is occurred, the voltage on the bus equals to VCC. So we can divide the communication format into 3 stages. The first one is the request stage, which microcontroller sends to the DHT11 sensor. Another one is the response stage. In this stage, the DHT11 sensor responds to the microcontroller previous command, and then here comes the data stage. Now coming to the first stage, the request stage. To make the DHT11 to send you the sensor reading, you have to send it a request. The request is to pull down the bus for more than 18 milliseconds in order to give DHT time to understand it and then pull it up for 40 microseconds. So as you can see the logic analyzer diagram, this pulse which we sent as the request is in the request stage is of 18 millisecond nearly, and then 18 millisecond low, and then it is around it is around 44.31 microsecond, but as per datasheet we have to send 40 microsecond high, but this will work as sometimes logic analyzer creates some error while measuring the signals. Now coming to the response stage, in this stage DHT automatically replies you with a 50 microsecond low and 80 microsecond high. So you can see this is the these 2 pulses are from the DHT11 sensor, and this is 50 microsecond low pulse and this is 87 microsecond high pulse. So as per datasheet, this should be 50 microsecond and this should be 80 microsecond. So which is almost equal as per the datasheet. Now the next stage is the data stage. The data will be packed in a packet of 5 segments of 8 bit each. In total, 5 into 8 equals to 40 bits. 40 bits will be received by the microcontroller from the sensor, out of which first 2 segments are humidity values, the integral and decimal values. The next one is the Celsius temperature values in Celsius, again which is integral and decimal values, and the last byte is the checksum byte, which is the sum of 4 first segments. If the checksum value is not the same as of the first 4 segment, that means the data is not received correctly. Now the question arises how we will detect the logic low and logic high. So if a low pulse of 54 microsecond and high for 24 microsecond is there, it means it is logic 0. And if a low pulse of 54 microsecond and a high of 70 microsecond, which means it is a logic high. So if you can see, this is a 54 microsecond low pulse and 24 microsecond high pulse. So it means this is bit 0. Similarly, this is bit 0, this is bit 0. Now coming to this is logic low of 54 microsecond and logic high of 71.5 microsecond. So it means this is high pulse. Similarly, this is high pulse, this is high pulse, this is low pulse, this is high pulse. So by decoding these values with our microcontroller, you can calculate the values of temperature and humidity. So we programmed the Arduino with this sketch, and you have to download the DHT11 library, which is given in the blog, so you can download the correct library from there. Now just test how it runs. See, my room temperature is 30 degrees Celsius and the humidity here is 44. Actually, you will see that the temperature value is quite high. This is because while starting recording this video, I accidentally connected VCC and ground in opposite manner, so my sensor gets heat up. That's why I am getting this high value. Hey guys, one cool updation to this project. We have created a LabVIEW GUI which will show the temperature and humidity graph on the display. As you can see, the temperature is being plotted with the number of samples received, and similarly the humidity plot is also there. So guys, please like this video, share this video, comment on this video if you have any doubt, and please don't forget to subscribe. Please subscribe to this channel. Thank you so much for your support, guys.